welcome back for another 7 Caillou challenge called Simple Fun number 176, Reverse Letter. Task: given a string as input, reverse it and omit all non-alphabetic characters. Check out the examples. You have this name Cretan, I think that's a name, and when it's only letters, it's really simple, right? You just return the letters reversed. C-N-A-H-S-I-R-K, it's just backwards. For string, kind of starts out with this ultra looking thing, and then you get the 5, 3, and a question mark. Notice that it goes backwards again, but the question mark's gone, the 3 and the 5 are gone. So, anything else to note? A string consists of lowercase Latin letters, digits, and symbols. Okay, so nothing else really to know here. I'm going to format mine while you pause this and have a go at it. And then I'll go into my solution. Or we're going to go over a few solutions. I'm going to do the typical thing I do where I kind of show you using basic building blocks, like if you don't know much LINQ, or how you can do it without LINQ, and then we'll leverage some LINQ and some other stuff. So let's get to it. First things first, what I'm going to do is sort of build the result in place, and to get the reverse effect, we often use for loops to go over input, and we're going to do that here, but instead of the usual I equals 0, I'm going to start at the end of the string, I equals string length minus 1, and then I'll decrement the index every loop, and we'll work back toward the front, and that's how I'll sort of achieve the reversal part. And then we're going to run a simple filter to determine if characters are letters or not. So I'll initialize this result where I'll sort of build my, well, result. And then, like I said, int I equals string length minus 1. Remember, indices of arrays, a string is a character array, right? Under the hood, it's just an array of characters. You can think of it that way anyway. It's more than that, but arrays are indexed with 0 base numbering. That's why I have to go length minus 1 instead of length. If we used length, we would overrun the bounds of the array, and that would be bad news. And so I'll say, as long as I is greater than or equal to 0, right? Element 0 would be the first letter. We do want to get that 2, so I put greater than or equals to, because I want 0. And then minus I, decrement I each time through the loop. So hopefully you can see how we're kind of walking backwards through the letters of the string here. Now, this is the critical part where we filter out letter and non-letter. I should say we filter out non-letter input. And if only there were a convenient way to do that. Well, there is. If you Googled it, you probably found in the char class, character class, right? We know chars. If you expand its methods and go down, you'll find one called isLetter. Indicates whether a Unicode character is categorized as a Unicode letter. That's more descriptive than we really need here. I just want to show you, here's a good example. So they initialize the character to the number 8, and then they right line, hey, is this a letter? Clearly 8's not, so it would return false. And then they run the same thing on this test string, sample string, and I assume this means the 7th index, so it would be, again, be a letter, because everything in here is letters minus the white space. 0, 1, 2, 3, 4, 5, 6, 7. So I think it would be this S in string, and that returns true because S is a letter. And we can look at the overloads to make sure I'm not just making that up. I'm just assuming when you give a second parameter there, it's indexing into your input string. Let's see. Yeah, it's right here. Here's the overload. Yep, at the specified position. So yeah, you can do that too if you need to. We won't need to, although I suppose we could use it. Either way is fine, however you want to do it. Let's just get into it. So char is letter, and then you throw the character in there. I'm just going to throw the character directly in there. I can say string, the input string at index I. So if that is a letter, then we want it, right? We'll say result plus equals str, I. And then by doing nothing else, we basically ignore when str at index I, whatever letter we're looking at, or I should say character we're looking at, because it might not be a letter, then it will skip that. If it doesn't meet this condition, it will skip and do nothing. So it's like we just pass over it, because right, we come back up to the for loop, I is decremented, and we go to the next character, and we never did anything. So you can just imagine it sort of falling away and being ignored. And then by the time our for loop completes, we can return the result. Now, we're going to improve on this, but I just want to show you can do these things with really simple logic. And sometimes writing them out on your own is, just as efficient or more efficient. So we passed all tests. Let's make sure we hit the full suite before we claim victory. And good. I don't know what this, I was getting this warning at line 106. I don't even have 106 lines, so don't worry about it if you're getting that too. I'm just ignoring it. We're green. So one more thing I want to bring to your attention, which I've done in the past, is that strings are not mutable, even though they act like they are. So when you look at this code and you see how I'm just adding a character to the string at a time, it looks very much like it's mutable. But underneath the hood, it's actually creating a new string and reassigning it to result. So if you're doing this for a large input, it can be quite inefficient. And there's something you should know about called the StringBuilder class. And it's more like a mutable string. And so you initialize it like this. You can even give it starting text, I believe. Go ahead and pull up the document page if you want more information on that. But if you're starting with no input, like I did with my string result here, you can just leave it empty in the constructor. And so it's slightly different in that when you add to a string builder, you use a method called append. There's no plus equals. So I'll say string builder append, and it's the same difference as when I used a normal string. You can think of it just like plus equals. Same thing, we ignore if it's not a letter, and then by the time we're done, the result's slightly different with the string builder too. You say string builder to string, and that will force it back to the string type that's expected here. And so we didn't define string builder. I need to bring in that logic, and if you have the doc page open, you'll know that here. Let's see if we can search. Let me show you just so you can see. See how it resides in the system text namespace, and I don't have that, so I'm going to have to bring that in. And then while you're here, you can look at, get some more information on it. I'm sure it will describe much better than I did about the difference between it and a string and when you might want to use it. But I gave you the, the quick gist of it. But anyways, let's bring in that system text namespace. I don't know why they put the using down there. I like it up here. Using system text. So now we shouldn't get yelled at. Now this should be basically the same. And the tests that they're running here are probably small enough in size where if you timed these, running these methods, it would, maybe there aren't huge performance gains. But if you had a large enough input, hopefully you would see that string builder was more efficient. I assume, I have to assume that if they went to the trouble of making it, there's some reason for using it. And I think you would see that. I have to believe it's quite wasteful to keep throwing away strings and creating new ones, throwing away memory, grabbing memory, reallocating memory again. But anyways, I like this one. Whenever I modify strings a lot, I prefer to use a string builder. That's sort of the general rule that'll get you there. So good. We improved the basic way of doing this a little bit. Now let's knock this thing out with a LINQ statement and get a little fancier, right? So I'll clear this out. And so if you had your enumerable methods open like I told you to keep a tab open, it's just helpful. You don't have to, it's helpful. But with the methods expand, it's good to just regularly scroll through these, and they start to just, you memorize them. You know what's available to you. And so maybe you found this reverse, and that'll handle that for loop we did where we started at the end and and decremented towards the front, we can use a reverse method to do that. And strings are enumerable, so we can call that. We're going to have to say using system LINQ to use those methods. Now what we can do then, we can say string reverse. And so it's just what the input was, and it's reversed in characters. So this is half the problem, right? But remember the instructions told us that we had to get rid of anything that wasn't a letter. So do you remember which one of these methods we use when we want to filter? I hope that's starting to trigger something for you. Where, right? So if we said where, and remember, string reverse is just the same string, but now it's an IEnumerable. These LINQ methods return just this generic collection. I just like to think of it as a generic collection of some general type. And then, so that's what we have at the point we're calling where. So each element is going to be a character, so I'll call mine CH. I often use that parameter name for a character. You can call yours with something meaningful to you. And then we're basically going to use the same logic. Say char is letter, just like before, CH. It's going to pass in each reversed character, and it's going to pass through the ones that are letters, because that's what the filter condition is. Filter where the character you're looking at from the original string that's reversed is a letter, and then pass it through. And so again, where returns an IEnumerable. I can't just return this, and I can show you that. It's going to say, you know, you can't convert IEnumerable to string or something. Cannot implicitly convert type IEnumerable of type char. That's what string. That's what these reverse and where are returning. And if you go to those methods, you can. Every doc page says what type they return. In fact, let's just show you. When you go to these, what I'm on reverse now. Scroll down, returns an IEnumerable of tsource. We're a string, so we have characters in there. So you can see that. You don't have to just believe me. You can verify all this stuff. And so, yeah, that makes sense, right? It's saying this is the contract. You got to return a string. So the question is, how do you get from this IEnumerable of char to string? Well, one thing you could do, if you know your strings, we notice that also at our disposal is we have this array. And so we can construct a string from an array of characters. Let me go to the string class. This is StringBuilder. Let's go to string. Okay, let's go down to the constructors. I'll just click on. There should be one that takes an array. There you go, bam. Look at this one, takes it. So you can make a string out of an array of characters. So we can combine these two ideas. We could say, okay, we got our filter, so now we have this IEnumerable of character, of char, that's only letters now. Let's make it into an array. And then, again, this is a character array. If I try to run it, it's going to say, you can't convert a char array to a string, but we're getting closer, right? We know that we can construct a string from a char array. I just showed that on the string page, right? So what you can do then is make a string out of this. And this, I would think, would work. Let's hit it. Green. And green. So I'm going to submit mine like this. Nice one-liner that's short and very clear, in my opinion. Nothing else to clean up. I don't have any comments in here, so let me fire this one off. And then you know the drill from here. Go ahead and look. Yeah, I mean, that's like what we did. Okay, so the ordering's a little different, right? See, you could have come up with lots of things. They even used a regex here, regular expression. That's cool. So anyways, feel free to look through those. Hit me up with your questions and comments. I really appreciate the likes and subs that are coming in. That means a lot to me, guys. The more of that I get, the more motivation it is for me to keep putting content out. So thank you very much for that. I'll see you in another video. Until then.